Chapter 10. Electrostatics. Exercises pages 205 to 206. Exercises Q1. Page 205. Choose the correct option. A positively charged glass rod is brought close to a metallic rod isolated from ground. The charge on the side of the metallic rod away from the glass rod will be 1. Same as that on the glass rod and equal in quantity 2. Opposite to that on the glass of and equal in quantity 3. Same as that on the glass rod but lesser in quantity 4. Same as that on the glass rod but more in quantity. Solution. Same as that on the glass rod and equal in quantity. Exercises Q1. Page 205. Choose the correct option. An electron is placed between two parallel plates connected to a battery. If the battery is switched on, the electron will 1. Be attracted to the plus bay plate 2. Be attracted to the bay plate 3. Remain stationary 4. Will move parallel to the plates. Solution. An electron is placed between two parallel plates connected to a battery. If the battery is switched on, the electron will be attracted to the plus bay plate. Exercises Q1. Page 205. Choose the correct option. A charge of plus 7 microcoulombs is placed at the center of two concentric spheres with radius 2.0 cm and 4.0 cm respectively. The ratio of the flux through them will be 1. 1. 4 2. 1. 2 3. 1. 1 4. 1 16. Solution 1. 1. Explanation. The total flux is independent of shape and radius. Exercises Q1. Page 205. Choose the correct option. Two charges of 1.0 C each are placed 1 meter apart in free space. The force between them will be 1. 1.0 N2. 9 times 109 N3. 9 times 10 to 9 N4. 10 N. Solution. Exercises Q1. Page 205. Choose the correct option. 2-point charges of plus 5 microcoulombs are so placed that they experience a force of 8.0 times 10 to 3 N. They are then moved apart so that the force is now 2.0 times 10 to 3 N. The distance between them is now 1. 1/4 the previous distance 2. Double the previous distance 3. 4 times the previous distance 4. Half the previous distance. Solution. Exercises Q1. Page 205. Choose the correct option. A metallic sphere isolated from ground is charged to plus 50 microcoulombs. This sphere is brought in contact with other isolated metallic sphere B of half the radius of sphere. The charge on the two sphere will be now in the ratio 1. 1. 2 2. 2. 1 3. 4. 1 4. 1. 1. Solution 1. 1 explanation. When two conductors, one charged and the other uncharged, are brought in contact with each other, the charge, whether minus V or plus V, under its own repulsion will spread over both the conductors. Thus, the conductors will be charged uniformly with the same sign. Exercises Q1. Page 206. Choose the correct option. Which of the following produces uniform electric field? 1. Point charge 2. Linear charge 3. 2 parallel plates 4. Charge distributed and circular any. Solution. 2 parallel plates. Exercises Q1. Page 206. Choose the correct option. 2-point charges of A equals plus 5.0 microcoulombs and B equals minus 5.0 microcoulombs are separated by 5.0 centimeters. A point charge C equals 1.0 microcoulombs is placed at 3.0 centimeters away from the center on the perpendicular bisector of the line joining the 2-point charges. The charge at C will experience a force directed towards 1. Point A 2. Point B 3. A direction parallel to line AB 4. A direction along the perpendicular bisector. Solution. A direction parallel to line AB. Explanation. The situation resembles a point along the equatorial line of a dipole. Therefore, force directed would be along a direction parallel to line AB. Exercises Q2. Page 206. Answer the following question. What is the magnitude of the charge on an electron? Solution: the magnitude of the charge on an electron is 1.6 times 10⁻19 C. Exercises Q2. Page 206. Answer the following question. State the law of conservation of charge. Solution: in any given physical process, the charge may get transferred from one part of the system to another, but the total charge in the system remains constant, or for an isolated system, total charge cannot be created nor destroyed. Exercises Q2. Page 206. Answer the following question. Define a unit charge. Solution: unit charge, 1 coulomb, is the amount of charge which, when placed at a distance of 1 meter from another charge of the same magnitude in a vacuum, experiences a force of 9.0 times 109 N. Exercises Q2. Page 206. Answer the following question. Two parallel plates have a potential difference of 10 volts between them. If the plates are 0.5 millimeters apart, what will be the strength of the electric charge? Solution. Exercises Q2. Page 206. Answer the following question. What is a uniform electric field? Solution: a uniform electric field is a field whose magnitude and direction are the same at all points. For example, the field between two parallel plates is shown in the diagram. Uniform electric field. Exercises Q2. Page 206. Answer the following question. If two lines of force intersect at one point, what does it mean? Solution: if two lines of force intersect at one point, it would mean that the electric field has two directions at a single point. Exercises Q2. Page 206. Answer the following question. State the units of linear charge density. Solution: SI unit of lambda is C per meter. Exercises Q2. Page 206. Answer the following question. What is the unit of dipole moment? Solution. Exercises Q2. Page 206. Answer the following question. What is relative permittivity? Solution. Exercises Q3. Page 206. Solve numerical example. Two small spheres 18 centimeters apart have equal negative charges and repel each other with the force of 6 times 10 to 8 N. Find the total charge on both spheres. Solution. Exercises Q3. Page 206. Solve numerical example. A charge plus Q exerts a force of magnitude minus 0.2 N on another charge minus 2Q. If they are separated by 25.0 centimeters, determine the value of Q. Solution. Exercises Q3. Page 206. Solve numerical example. Two charges 5 microcoulombs and minus 4 microcoulombs are kept 5.0 meters apart at points A and B respectively. How much work will have to be done to move the charge at A through a distance of 5.0 meters further away from point B along the line BA? Solution. Given Q1 equals 5 microcoulombs equals 5 times 10 minus 6 C, Q2 equals 4 microcoulombs equals minus 4 times 10 minus 6 C, R1 equals 5 meters to find. Work done W. Exercises Q3. Page 206. Solve numerical example. Four charges of plus 6 times 10 to 8 C each are placed at the corners of a square whose sides are 3 centimeters each. Calculate the resultant force on each charge and show in the direction in a diagram drawn to scale. Solution given. QA equals QB equals QC equals QD equals 6 times 10 to 8 C, A equals 3 centimeters. Magnitude of force on A due to D is. Exercises Q3. Page 206. Solve numerical example. The electric field in a region is given by equals 0.5 kN/c. Calculate the electric flux through a square of side 10.0 centimeters in the following cases. The square is along the xy plane E. The square is along xz plane E. The normal to the square makes an angle of 45 degrees with the z-axis. Solution. Electric flux in the above-mentioned cases are 5 times 10 minus 2 Vm, 0 vm, and 3.5 times 10 minus 2 vm. Exercises Q3. B page 206 solve numerical example. 3 equal charges of 10 times 10 to 8c respectively, each located at the corners of a right triangle whose sides are 15 centimeters, 20 centimeters, and 25 centimeters respectively. Find the force exerted on the charge located at the 90 degrees angle. Solution. Given QA equals QB equals QC equals 10 times 10 to 8c. Exercises Q3. B page 206 solve numerical example. A potential difference of 5,000 volts is applied between two parallel plates 5 centimeters apart. A small oil drop having a charge of 9.6 times 10 to 19 C falls between the plates. Find A. Electric field intensity between the plates, and B. The force on the oil drop. Solution. Given B equals 5,000 volts, D equals 5 centimeters equals 5 times 10 to 2 m, Q equals 9.6 times 10 to 9 C. To find A. Electric field intensity E. B. Force F. Exercises Q3. B page 206. Solve numerical example. Calculate the electric field due to a charge of minus 8.0 times 10 minus 8 C at a distance of 5.0 centimeters from it. Solution.
Set your place on fire.